During the day, the ocean is open and understandable. Light glides across the surface, reflects in the waves, making the water transparent and vibrant. Even in a storm, the daytime ocean remains visible. Its movements can be traced with the eye, its color changing depending on the sky. But as the sun begins to set below the horizon, the ocean gradually ceases to be what we're used to seeing. First, the hues fade. The blue becomes darker, more saturated. The sunset's gold dissolves into the water, leaving only a soft glow on the horizon. The surface still moves. The waves continue to roll, but their shape becomes less distinct. The contours lose their sharpness. There comes a moment when the boundary between sky and water almost disappears. The evening haze blurs the horizon. Space seems endless. It's no longer clear where the water ends and the sky begins. Night doesn't come instantly. It descends slowly over the ocean. First, the stars appear, then the darkness deepens, and the water stops reflecting color. It begins to reflect light in pinpoints. The moon, if present, creates a silvery trail on the surface. Without it, the ocean becomes a dark mirror. As darkness falls, not only the view changes, but also the sense of scale. During the day, distance can be judged by the color of the water, the clouds, and the coastline. At night, landmarks disappear. Even a small vessel on the open ocean can feel like a tiny dot in the vastness of space. The ocean surface appears deeper at night, not because the depth increases, but because visual contact with it disappears. During the day, you can see glare on the waves, bright spots, and transparency near the shore. At night, everything becomes one dark expanse. Interestingly, surface water temperatures can fluctuate slightly overnight. Without solar heating, the upper layer begins to cool. This cooling affects air movement, fog formation, and local winds. In coastal areas, the wave pattern changes at night. When the wind abates, the surface becomes smoother. Sometimes the ocean at night appears almost smooth, like black glass. At such times, the reflection of the stars creates a sense of depth, not only downwards, but also upwards. There's a special moment when the light completely disappears, but your eyes haven't yet adapted to the darkness. At this moment, the ocean appears dense, almost opaque. But after a few minutes, shapes begin to emerge. The faint outlines of waves, the silhouette of a mast, the horizon. Night intensifies the sound. The sound of the surf becomes more distinct. Even the slightest movement of the water is heard louder because there are fewer visual distractions. In the open ocean, the soft rhythm of the waves hitting the ship's hull can be heard. For marine organisms, night signals a change in behavior. Vertical migration begins in the upper layers. Billions of small creatures rise closer to the surface. This is one of the largest daily movements of biomass on the planet. During the day, they hide in the depths, avoiding predators. At night, in the darkness, they rise to the upper layers to feed on plankton. The ocean doesn't stop at night. It becomes different. From the shore, the water appears calmer, but beneath the surface, movement begins. Fish, squid, and small crustaceans become active. Some predators prefer the nighttime. The moon plays a special role. During a full moon, the ocean surface may be illuminated enough to discern the silhouettes of waves. The water takes on a silvery hue. During a new moon, the ocean becomes almost completely black. In the open ocean, far from cities, the darkness can be so deep that the stars are reflected in the water more brightly than on land. On such nights, it feels as if the boat is sailing between two heavens. There's another side to this. A storm feels different at night. Without daylight, it's hard to judge the height of the waves. You can only hear their roar and feel their rocking. In the dark, the scale seems larger. For a person, a night in the ocean always heightens the senses. Space becomes more abstract. Direction is difficult to determine without instruments. Depth is felt more intensely. If you imagine the open Pacific Ocean at night, far from any shore, you can feel absolute isolation. There are no lights around, no landmarks, only stars and water. And somewhere beneath this dark surface, a glow begins. We'll talk about it later. When the sun sets below the horizon, the ocean surface doesn't simply darken. It gradually changes its behavior. This doesn't happen instantly, but in several stages that are almost impossible to notice unless you're paying close attention. First, the color fades. Blue becomes a deep indigo. Then the water begins to absorb the hues of the sky. If the sunset was bright, the last streaks of pink and orange dissolve into the surface, as if the ocean were claiming them. Within minutes, you can see the light drain from the waves and the crests lose their distinct outlines. 20 to 30 minutes after sunset, the horizon begins to blur. The boundary between sky and water becomes not a line, but a transition zone. In tropical latitudes, this moment is especially noticeable. The light fades quickly, and the ocean seems to plunge into a deep blue shadow. In the central Pacific, night feels different than near the coast. There's no coastal noise, no harbor lights, no reflections from buildings. When the sun disappears, the darkness becomes total. Sometimes so total that even your own hand at arm's length seems barely visible. At such moments, the surface ceases to be reflective. It becomes absorbent. Interestingly, the wave dynamics also change at night. During the day, surface heating increases air movement, creating turbulence. At night, the surface begins to cool. In some areas, the wind subsides almost completely. Then, long ocean waves continue to travel, but their height decreases and they become smoother. Sailors call this state black glass. The water appears smooth, almost mirror-like, and if there are stars in the sky, they are reflected without distortion. In the middle of the Pacific Ocean, you can see a rare phenomenon. The starry sky is so bright that it creates the feeling that the boat is sailing between two heavens, one above, the other below. Expeditions described instances where, in a completely calm sea, the horizon disappeared completely. Water and sky merged into a single dark sphere. People lost their sense of direction. Only navigational instruments confirmed their movement. But the night is not always calm. If the wind picks up, the surface begins to change more quickly. Waves grow, but they are difficult to judge. In the dark, it's impossible to determine the exact height of the crest. Sometimes a wave lifts the boat so smoothly that its scale is only felt a few seconds later, when the boat begins to descend. A storm at night is a special surface condition. The splashes of water aren't fully visible, only their sound. If there's lightning, it illuminates the area with short flashes. At this moment, the water's contours can be seen, huge dark masses rising and falling. After the flash, complete darkness sets in again. There are also more rare phenomena. Sometimes glowing streaks can be seen on the surface of the warm Pacific Ocean at night. This is due to the concentration of microorganisms that react to the slightest movement of the water. Even a light wind can create long glowing lines along the waves. In 1985, the crew of a research vessel described how, on a moonless night, the ship's entire wake transformed into a glowing road hundreds of meters long. Every turbulence activated millions of cells. From the surface, it looked as if the ship was floating through a liquid starry sky. In tropical areas, flying fish are often seen leaping out of the water at night. Their bodies appear as short shadows against the starry sky. Sometimes they fly several dozen meters before touching the surface again. Dolphins also become more visible at night. Their movements create flashes of light. In the dark water, a luminous arc, the animal's silhouette, can be seen passing beneath the boat. At night, the air temperature over the ocean often drops faster than the water temperature. This creates a slight instability in the atmosphere. Sometimes a light fog forms over the surface. This makes the water seem almost unreal, as if it were floating in midair. There are areas in the Central Pacific Ocean where you can go for hours without seeing a single light on the horizon. It's one of the most isolated areas on the planet. At such moments, the ocean surface becomes not just water, but a sense of scale. A man stands on the deck, surrounded by only dark water and stars. There's not a single landmark, and beneath this surface lie kilometers of depth. And it is at this time that movement begins under the water. There's a moment when the ocean's night ceases to be simply dark. The water begins to respond to movement with light. At first, it might be a barely noticeable flash, like a spark in the black depths. Then a whole trail of bluish glow appears behind the ship's stern, and sometimes flashing waves that, for a second, turn the surf into a luminous line. This isn't a reflection of the moon or phosphorus in the water. These are living organisms. Bioluminescence is the ability to emit light due to a chemical reaction within a cell. The process is based on the interaction of special molecules, luciferin and the enzyme luciferase. When they react with oxygen, energy is released in the form of cold light. This light doesn't heat the water. It's soft, usually blue or greenish. These shades are best distributed in the marine environment. At night, the ocean surface may appear normal, dark and calm. But just brush your hand through the water or paddle a boat, and a glowing trail appears around you. Every movement causes flashes. Dinoflagellates, microscopic organisms that glow when mechanically disturbed, are particularly common in the warm waters of the Pacific Ocean. When a wave breaks on the shore, millions of these cells simultaneously light up, momentarily transforming the surf into a glowing line. In the open ocean, light is most often visible behind a moving vessel. Water turbulence triggers the reaction, making it appear as if the ship is leaving a luminous trail behind. Sometimes light appears in the depths. If you lower your camera underwater at night, you can see occasional flashes in the darkness. These are not uniform glows, but short pulses. Bioluminescence serves a variety of purposes. Some organisms use it as a defense. A sharp flash can disorient a predator. Others use it as a way to attract prey. Still others glow to attract a mate. In the middle layers of the ocean, the twilight zone, luminous organisms are especially numerous. Where sunlight no longer reaches, bioluminescence becomes the primary source of visible light. If you imagine a night in the open Pacific Ocean, far from the shore, you can see this phenomenon in its full glory. The sky is strewn with stars, the water's surface is dark, and suddenly, with the slightest movement, blue sparks appear. In moments like these, it's hard to separate science from the sense of wonder. Light literally emerges from the darkness. Sometimes bioluminescent organisms gather in dense clusters. Then entire areas of water begin to glow softly. This glow can last for seconds or minutes, then fade. There are rare cases where light covers large surface areas. Glowing patches of ocean stretching tens of kilometers have been recorded from space. This phenomenon is called a Milky Sea. It occurs when a huge number of luminous bacteria concentrate in one area. Underwater, light appears differently. A camera submerged in dark water records faint flashes around itself. Sometimes you can see the silhouette of a fish surrounded by a halo of light, microorganisms reacting to its movement. Some deep-sea creatures produce their own light. Anglerfish use glowing bait. Shrimp can emit a cloud of luminous liquid to distract predators. Jellyfish pulsate with a soft blue light. Interestingly, in absolute darkness, even a faint flash appears bright. The eye adapts, and the slightest light becomes noticeable. If you find yourself in the open ocean at night and dip your hand into the water, you'll see your fingers leave a glowing trail. It's a feeling you'll never forget. Bioluminescence is a reminder that even in the dark, the ocean isn't empty. It's alive. Light does not come from outside. It is born inside the water. And the deeper we dive, the more often this living light becomes the only source of visibility. But along with the light, life also becomes more active at night. When the surface darkens and the last glimmers of sunset fade, the ocean doesn't fall asleep. It seems to switch to a different mode of existence. While during the day, life is distributed more statically among layers, at night, the water begins to move differently, not as waves, but as creatures. Vertical migration is the largest daily movement of living matter on the planet. This is not poetic exaggeration, but a scientific fact. Oceanographers estimate that every night, billions of tons of biomass rise closer to the surface and then return to the depths before dawn. This process begins at dusk. Initially at a depth of 500 to 700 meters, the density of small organisms increases. Then the layer gradually rises. On echo sounders, this appears as a living boundary moving through the water column. Zooplankton, krill, and small crustaceans all spend the day in the depths, where the light is weaker. There, they are harder for predators to spot. At night, when the surface darkens, they rise to feed on phytoplankton and organic particles. Imagine the volume of the Pacific Ocean. Now imagine this movement beginning simultaneously across vast expanses. It's not a storm, not a splash. It's a slow, almost silent rise of living mass. In tropical regions of the Pacific Ocean, the density of small organisms in the upper layers can increase several times at night. Research vessels have recorded zooplankton concentrations rising so much within an hour that the water literally shimmers in the spotlight beams. Small organisms are followed by predators. Lanternfish are a distinctive nocturnal species. Their bodies are equipped with rows of luminous organs. These lights serve both communication and camouflage. From below, their light matches the faint light coming from above, making their silhouette almost invisible. Some squid species become more active at night. Their movements are fast and precise. Cameras on deep-sea submersibles have recorded squid hunting for rising zooplankton using brief flashes of light for orientation. Some sharks prefer to hunt at night. For example, the blue shark often rises closer to the surface at night. Its sensory system allows it to detect the weak electrical signals of its prey. In coastal areas, life changes almost completely. Coral reefs appear vibrant and active during the day, but many of their inhabitants hide. At night, the reef becomes another world. Crabs emerge from their hiding places. Starfish slowly move across the coral surface. Octopuses go hunting. An observation made off one of the Micronesian islands revealed that an octopus, which barely moved during the day, traveled more than 30 meters across the reef at night in search of prey. It changed color, blending in with the dark areas and moving almost silently. In the open ocean, life is no less active, but less visible. At depths of 200 to 300 meters, dense schools of small fish can be seen at night, which are much lower during the day. These schools attract larger predators such as tuna and barracuda. During one expedition in the Central Pacific Ocean, researchers lowered a camera to a depth of about 150 meters at night. The beam of light revealed so many tiny organisms that the water appeared thick, as if filled with dust. It wasn't dust. It was living creatures. Interestingly, some species of jellyfish rise to the surface at night. Their translucent bodies become visible only in a beam of light. They pulsate slowly, as if moving in slow motion. There are deep-sea shrimp that can eject a cloud of luminous liquid when threatened. At night, this appears as a brief burst of light in the darkness. In the twilight zone, at depths of 200 to 1,000 meters, the number of bioluminescent organisms is particularly high. There, light is not a rarity, but a means of survival. Every movement can cause a flash. In the Hadal zone is more sparse, but there are nocturnal cycles there too. Some deep-sea fish ascend several dozen meters, depending on the time of day. The ocean's nocturnal life isn't a noisy activity. It's a gradual increase in movement that's difficult to detect without instruments. And it is at night that the ocean shows that it is never empty. Even though the surface appears calm, beneath it the planet's largest migration is taking place. And all this without sound, without light, without witnesses. At night, the ocean seems quieter. There's no bright light, no visual movement, and so attention gradually shifts to sound. But the ocean's silence isn't the absence of sound, it's its particular distribution. During the day, the surface is filled with noise, wind, surf, birdsong, boat engines. At night, many of these sources disappear or weaken. The background rhythm of the water remains, soft, repetitive. In the open Pacific Ocean at night, the sound becomes clearer. The wind noise fades, and only the lapping of waves against the ship's hull can be heard. Occasionally, the gentle swish of water as it glides alongside. When you lower the hydrophone underwater, the soundscape becomes more complex. Even in the dark, the ocean is not silent. Whales' low-frequency calls can travel through hundreds of kilometers of water. These sounds are deep, drawn out, almost vibrational. The human ear perceives them as a hum or distant echo. Some whale species are more active at night. Their calls become clearer against the reduced surface noise. Clicks and pulses can be heard in the middle layers of the water, the sounds of small organisms. Shrimp produce a characteristic crackling sound, reminiscent of electrical sparks. In coastal areas, this noise can be almost continuous. As the depth increases, the sound becomes muffled. Water pressure and density affect its propagation. In the Hadal zone, the sound is perceived as a rare vibration rather than a clear signal. Sometimes hydrophones detect unusual sounds, long, low-pitched signals whose origin initially remains unknown. Some of these turn out to be associated with ice fractures or underwater earthquakes. There's a special phenomenon called the ocean sound channel. At a certain depth, conditions arise where sound can travel thousands of kilometers with virtually no loss. At night, when surface noise decreases, these signals become more noticeable. If you imagine yourself inside a submersible at night at a depth of several kilometers, you can hear only the faint metallic hum of the structure and rare vibrations. The absence of light intensifies the perception of sound. Even the faintest splash seems louder. The space becomes acoustically more expressive. There are also moments of complete silence. When there's no wind, no waves, No nearby organisms, sound seems to vanish. In such moments, the ocean seems motionless. But even then, somewhere far away, a low-pressure wave may be passing, the result of a tectonic shift or a distant storm. Night changes perception. Sound becomes the main reference point. In the middle of the Pacific Ocean, far from shipping lanes, you can spend the night without hearing anything but the water and your own breathing. This silence isn't frightening. It creates a sense of space, and the deeper the night becomes, the more this space is felt, not only around, but also below. Next, let's look at what night storms and thunderstorms look like over the ocean. At night, a storm feels different. During the day, you can see it. The lines of the waves, the gray sky, the movement of the clouds. In the darkness, only sound and movement remain. The ocean ceases to be a painting and becomes a force. First, the air changes. It becomes denser, heavier. The wind gradually increases. The waves begin to grow, but their shape is difficult to discern. Only white crests are visible if there's moonlight, or brief flashes if lightning flashes in the distance. In the open Pacific Ocean, a storm can last for hours or even days. At night, the scale of the waves is more acutely perceived. Without a visual reference, it's difficult to estimate their height. Each wave seems higher than the last. The ship rises and falls in the darkness. The water hits the hull, leaving a dull, rhythmic sound. Occasionally, brief bioluminescent glows appear in the wave crests, luminous flashes, like sparks on the crests. Lightning over the ocean is especially vivid. In complete darkness, its flash momentarily illuminates everything. The uneven surface of the water, the contours of the clouds, the silhouette of a ship. Then darkness returns. Thunder sounds deeper in the open ocean. It doesn't reflect off buildings or mountains, but spreads freely across the water. The wind at night can seem stronger than during the day. It's piercingly cold. Raindrops on the surface of the water create thousands of tiny splashes. A storm in dark water isn't chaos, but the movement of a huge mass. Waves come in series, the rhythm changing. Sometimes there's a pause, and then a new group of higher waves arrives. In the central Pacific Ocean, far from land, storms are formed by heat stored in the water. At night, this heat continues to fuel atmospheric processes. The storm may be far away, but its light is visible on the horizon. Flashes illuminate the undersides of the clouds, creating a sense of depth in the sky. Sometimes, in the midst of a storm, the ocean surface becomes so dark that it appears solid. Waves become invisible. Only the sensation of rolling remains. For humans, a stormy night heightens feelings of vulnerability. Space becomes unpredictable. But for the ocean, this is a normal cycle of energy movement. Below the surface, everything looks different at this time. At a depth of several dozen meters, the storm is barely felt. The water movement is smoothed out. Lightning doesn't penetrate deeply. Life in the depths continues its rhythm, barely reacting to the storm above. This creates an interesting contrast. Chaos on the surface, stability deep down. When the storm passes, the ocean gradually returns to calm. The wind weakens, the waves become lower, the clouds disperse. And after a thunderstorm, the night can become especially quiet. The surface reflects the stars again. The air becomes transparent. At moments like these, the ocean seems even deeper. But there are places where the night remains almost absolute, without moonlight, without reflections. More about them later. There's a night over the ocean when the moonlight reflects off the water. when the stars create a silvery pattern on the surface. And then there's another night, moonless, cloudy, deep. At such times, the ocean becomes one of the darkest places on Earth, far from the shore, far from cities where there is no artificial light. Darkness feels different. At first, the eye sees nothing. The water's surface merges with the sky. The horizon disappears. If you close your eyes for a few seconds and then open them again, faint outlines gradually begin to appear. But this isn't light. It's the eyes adapting. In the central Pacific Ocean, you can find areas where light pollution levels are virtually zero. These are some of the darkest places on the planet in terms of the night sky. But the darkness over the water is only half the story. True darkness begins beneath the surface. At depths of just a few hundred meters, the last vestiges of daylight disappear. At night, this process is almost indistinguishable from daytime at depths where sunlight doesn't reach the water anyway. If you imagine diving into water on a moonless night, after a few meters, the light will disappear completely. Even the surface will cease to be a reference point. Deeper, in the bathypelagic and abyssal zones, the darkness is absolute. There are no stars, no moon, no glimmer of light. Only rare flashes of bioluminescence can momentarily break it. At the bottom of the ocean trenches, in the Mariana, Tonga, and other trenches, darkness has existed unchanged for millions of years. This is a space where daylight has never been. The darkest places on the planet are located right there, several kilometers below the surface of the Pacific Ocean. Interestingly, in such conditions, human perception loses its usual landmarks. If a person were there without lighting, they wouldn't even see their own hands. Darkness becomes not a background, but a medium. In the central Pacific Ocean, the surface can be so dark at night that even a small boat disappears into thin air. There's no shoreline, no lights, no city noise, just water and sky. Sometimes clouds completely obscure the stars. Then the darkness becomes dense, almost tangible. There's another place called the point of inaccessibility, the ocean's furthest point from land. At night, it feels especially isolated. Even if lightning flashes on the horizon, it will seem distant and faint. The darkest places on the planet are not just a geography, but also a feeling. In such spaces, time is perceived differently. Without light, it's difficult to judge distance. Without a horizon, it's difficult to grasp scale. But even in this darkness, the ocean is not empty. Movement continues beneath the surface. Small organisms migrate, predators hunt, and the water slowly shifts. Darkness does not mean the absence of life. She just hides it. And perhaps this is what makes the ocean at night so alluring, the combination of complete darkness and hidden movement. But how does a person feel when he finds himself in the open ocean at night? During the day, the ocean feels like space. You can measure it with your gaze. You can see the waves, the clouds, the horizon. Even if there's no land around, you still feel a sense of direction. At night, everything changes. When the sun disappears completely and the moon is hidden behind clouds, the ocean becomes abstract. The boundary between sky and water disappears. The human brain, accustomed to visual cues, begins searching for landmarks and finds none. The open Pacific Ocean at night gives a particularly powerful sense of scale. There are no city lights, no noises of civilization. Even other ships may be out of sight. Space becomes dimensionless. People perceive the world through light. When light is scarce, imagination begins to fill in the gaps. The gentle rocking of a boat may seem stronger. The sound of water against the side of the boat may seem louder. The wind may seem colder. In such conditions, feelings are intensified. Every sound becomes significant. Every reflection becomes noticeable. Sometimes, in the darkness, you can see a faint glow on the surface of the water. Bioluminescence. This creates the feeling that there is life beneath the boat, even if it's out of sight. A night on the open ocean evokes a variety of reactions. For some, it's tranquility. The monotonous rhythm of the waves and the lack of visual noise create a sense of solitude. For others, it's anxiety, a lack of boundaries. Psychologically, it's important for humans to understand their position in space. On land, there are walls, roads, and landmarks. In the ocean at night, there's nothing like that. If you look up, the starry sky can seem endless. If you look down, you see dark water, the depth of which is impossible to imagine. There is a feeling of vertical space, not only around, but also below you. Interestingly, many sailors described the night ocean as a place of special concentration. In the dark, there are fewer distractions. Attention is focused on the present moment. But there's a downside. Prolonged exposure to complete darkness can intensify feelings of isolation, especially in the Central Pacific, where the distance to land is measured in thousands of kilometers. The gentle rocking, the constant sound of water, the lack of a horizon, all this creates a feeling of separation from the world. There have been instances in the history of navigation when a night on the open ocean became a mental test, especially during storms, when visibility is near zero. However, many people note that it's at night that the ocean appears most sincere. It doesn't distract with bright colors, nor does it overwhelm with details. It remains simple: water and sky. In the dark, it's easier to feel the rhythm. The waves come and go. The boat rises and falls. Breathing becomes more noticeable. If you turn off all the lights on the boat and let your eyes adjust, you can see the faint glow of stars in the water. This creates the sensation that the boundaries of space are blurred. The psychology of the night ocean is a combination of vulnerability and tranquility. A person realizes their own smallness in the face of scale, and at the same time, they feel a connection with this space. And somewhere beneath the dark surface, the depth remains unchanged. Day or night, light or darkness. More on whether the depth changes at night. At first glance, it seems like night only affects the surface. The light fades, the air gets cooler, and the waves change their character. But if you dive underwater, the question arises: does the depth itself change when darkness falls? Physically, the depth remains the same. Pressure is independent of time of day. Temperature at great depths varies little, day or night. In the Hadal zone, at depths greater than 6,000 meters, conditions remain stable for years. And yet, the night matters. The upper layers of the ocean react most quickly. After sunset, solar heating ceases. Surface water begins to gradually cool. This cooling can cause slight mixing of the layers, especially if the wind picks up. At night, vertical migration of organisms peaks. Billions of small creatures rise closer to the surface, and this movement influences the distribution of biomass in the water. But at a depth of just a few hundred meters, the influence of day and night becomes almost imperceptible. Light doesn't reach there even during the day. If you imagine descending into the ocean on a moonless night, the first few meters will be completely dark. The surface will disappear almost immediately. But after 100 meters, 200, 500, the conditions will be the same as during the day. The depth lives by its own laws. In the bathypelagic zone and below, There is no day/night cycle. There are no sunrises or sunsets. Organisms navigate not by light, but by biological rhythms and water movement. Interestingly, at night, when the surface is darker, human depth perception is heightened. Standing on the deck, it's hard to imagine how many kilometers of water lie beneath you. But in complete darkness, the idea of depth becomes more tangible. The ocean seems deeper at night, not physically, but psychologically. Looking down into the black water, the imagination easily completes the space. The absence of light creates a sense of infinity. At great depths, where pressure exceeds hundreds of atmospheres, there is no difference between day and night. The temperature remains around 1 or 2 degrees. The water is dense and still. But there is one aspect that links night and the deep: bioluminescence. In the twilight zone, when the surface becomes dark, luminous organisms become more visible. Their flashes create the sensation that the deep comes alive. In the hadal zone, light remains rare. Life there is slow and almost imperceptible. If you imagine a bathyscaphe parked at the bottom of the Mariana Trench at night, nothing would change compared to the day. Outside the porthole, it would be the same darkness. This is one of the most interesting properties of the ocean. In the deep, night is constant. Sunlight reaches only the thin outer shell. Everything below lives in a world where time of day has no meaning, and there is a special sense of stability in this. The surface can be calm or stormy, light or dark, but in the depths, everything remains almost unchanged. The ocean changes at night for us, for those above water. For the deep, however, night is a constant, and perhaps it is this constancy that creates a sense of peace. Now we can move on to the finale, a slow one, uniting the surface, depth, and night into one space. Night on the ocean never begins abruptly. It doesn't fall from above and cover the water instantly. It dissolves into it, gradually erasing its boundaries. First, the colors disappear, then the contours, then the horizon itself. And at some point, only the dark surface remains, slowly moving beneath the stars. If you imagine the open Pacific Ocean, not a coastal zone, not a bay, but an expanse thousands of kilometers from land, the night there feels different. It has no background, no distant lights, no road noise, no glowing city on the horizon, only water and the sky. At such times, the planet seems to become simpler. It's as if Earth were returning to its original state, a dark, water-covered sphere rotating in space. The surface breathes slowly. Long ocean waves pass beneath the ship's hull. They don't break or make noise, but simply lift and fall. The rhythm becomes almost hypnotic. With every movement of the boat, barely noticeable sparks can flash in the water. Bioluminescence, brief traces of life. These flashes disappear as quickly as they appear. Somewhere in the water column, at a depth of several hundred meters, the nocturnal migration continues. Billions of tiny organisms rise to the surface and then sink back down. This movement is invisible from the deck, but it happens every night, without interruption, without witnesses. Deeper, at a depth of a kilometer, the darkness remains constant. There are no sunsets or sunrises. There is no moon. The pressure is constant. The water is dense and cold. Even deeper are the basins. Mountains lie there, unseen. Sediment settles slowly, layer by layer. Fish adapted to extreme conditions move slowly, economically. All this exists simultaneously. The surface appears calm, but beneath it lies a whole system of movements, temperatures, currents, and living organisms. If you stand on the deck at night and look into the dark water, it's hard to imagine its depth. The human eye sees only the reflection of the stars, but beneath that reflection there could be kilometers of water. Sometimes on a moonless night, the horizon disappears completely. Then space ceases to be horizontal. It becomes three-dimensional. Up there is an infinity of stars. Down there is an infinity of water. A person finds himself between them. This position, between the sky and the depths, creates a special feeling. Not anxiety or fear, but a sense of scale. The Pacific Ocean covers almost a third of the Earth's surface. Every night, this vast body of water plunges into darkness. Hundreds of millions of square kilometers turn black, and yet life goes on. Whales pass beneath the surface, emitting low-pitched calls. Fish shift depth. Microscopic organisms rise and fall. Even at the most remote point of the ocean, there is movement. Night does not stop the ocean. It makes it less visible. Perhaps this is why the ocean seems more honest at night. It doesn't distract with color, doesn't play with reflections, doesn't reveal the water's transparency. It remains water, slow-moving, deep, cold, alive. If you imagine the sunrise coming in a few hours, the light will restore the contours. The horizon will appear, the waves will turn blue, the sky will be bright, but the depth will not change. The migration will end, and the life layer will descend again. The storm may begin or subside. The surface temperature will change by several degrees, but at a depth of several kilometers, everything will remain the same. This feeling of permanence is one of the most peaceful thoughts one can experience. In a world where everything changes rapidly, the depth of the ocean remains almost unchanged. A night in the Pacific Ocean is not an event. It's the state of the planet. It comes, it lasts, it goes away, and it comes back again. If you imagine the Earth from space at night, you can see the lights of cities. But vast swaths of ocean remain pitch black. That's where night is most truly experienced. And somewhere in this darkness, water moves slowly. No rush, no sound, without borders. The surface reflects the stars. The depth keeps silence. And between them there is a space in which a person can simply stand and listen to the rhythm of the waves. A night on the ocean requires no explanation. She just exists. And as long as the planet rotates, it will return again and again, slowly, inevitably, calmly.